Good morning, students. Myself, I am Dr. Sanjay P. Yeole, HOD, SDSM Junior College, Department of Chemistry, Palghar. Students, our routine topic is elements of group 16, 17, and 18, that is unit number 7. In that, in previous lecture, we learn about introduction of periodic table. In that, configurations about the p block elements. Later on, their general configuration, including oxygen, sulfur, selenium, tellurium, polonium, as well as groups in 17 halogen family. In that we have learned fluorine, chlorine, bromine, iodine, acetylene, and at last we learn group 18 noble gases right from helium, then neon, argon, krypton, xenon, and radon. Then we learn about the occurrence of group 16 elements, then occurrence of group 17 elements, then occurrence of group 18 elements. Later on, atomic and uh, physical properties of the elements of group 16, 17, and 18 that we have to start now. In this topic, we comparatively study about the physical properties of all these three groups, with group 16, 17, and 18. One by one, we have discussed. First property is atomic and ionic radii. You know, what do you mean by atomic radii? It is the internuclear distance from center of the nucleus to the outermost shell, that is called as atomic radii. And about the ionic radii, that is same one, internuclear distance from the center of the nucleus up to the outermost shell of the ion, that is ionic radii. In group 16, atomic and ionic radii is increases down the group due to increase in their number of shells. You know, as the electronic configuration in that number of electrons are increases, this number of shells also increases. In case of group 17, it can be increases down the group due to increase in the number of the shells. In group 18, it indicates increase, it increases down the group due to increase in the number of the shells. Later on, in group 16, we see it is what less as compared to group 15 because of the increasing effective nuclear charge. Effective nuclear charge means what is the concentration of the electron toward the nucleus, that is effective nuclear charge. In group 17, it is less as compared to the group 16 because of increase in effective nuclear charge. While in case of group 18, it is more as compared to the group 17 due to inert gases which has van der Waals radii, which are larger than that of the covalent radii or ionic radii. You know very well covalent radii between the two atoms, about the ionic radii, that already we have discussed. Second property we discuss about the ionization enthalpy. Ionization enthalpy is that it shows the decrease down the group due to increase in the atomic size in case of group 16. While in group 17, decrease down the group due to increase in the atomic size. Group 18 in that decrease down the group due to increase in atomic size. Now about the atomic size, this ionization enthalpy can be affected comparatively in group 16, 17, and 18. Then it is less compared as compared to the group 15 because group 15 elements have stable electronic configuration, and that stability we can study with the help of their half field electron configuration. What do you mean by half field? In group 16, suppose one orbital has the capacity of 2 electron, in that one is present, that is half field. About the p orbital capacity 6 electron, in that 3 are present, as per the spin order these are half filled, like that. Group 17 in that it is more as compared to the group 16 because of increase in effective nuclear charge. You know very well what is the effective nuclear charge. Group 18, it is more as compared to the group 17 and highest in period because of increasing effective nuclear charge and shows stability with respect to their electronic configuration. You know group 18 elements almost stable. That's why ionization enthalpy has that type of comparable effect. It is highest in the period due to increase in effective nuclear charge. Next physical property we learn electronegativity. Electronegativity means what is the tendency to attract the electrons, which can be compared with the halogen atom also. In group 16, it is decreases down the group due to increase in atomic size. In group 17, it is decreases down the group due to increase in atomic size. In group 18, electronegativity of noble gases is not determined as it does not form compound. So comparatively we can discuss this one. Then in group 16 electronegativity about that it is the more as compared to the group 15 because of increasing in effective nuclear charge. In group 17 it is more as compared to the group 16 because of increasing effective nuclear charge. In this way we can compare these two groups about the electronegativity. Later on physical properties, in that it is what decreases electronegativity point. Same will continue. Electron gain enthalpy. In that electron gain enthalpy, group 16, in that it is decreased down the group due to increase in atomic size. Now exceptional case is about the oxygen. Oxygen has less electron gain enthalpy as compared to the sulfur because of small size of the oxygen. Electron cloud is spread over a region and charge density is higher, so it does not accept the incoming electron in the outermost shell of that element. That's why this variation we'll see. In group 17, it can be decreased down the group due to increase in atomic size, and in the exceptional cases fluorine has less electron gain enthalpy as compared to the chlorine due to small size of the fluorine. You know very well fluorine is very smallest element among the halogen. That's why it has got small size. Electron cloud is spread over a region and charge density is higher, so it does not accept the incoming electron. So in this way we can compare, and group 18 in that we can say it is what decrease down the group due to increase in atomic size. So about the halogen also, about inert gas also we can compare this one. So group 16, 17, 18 we can compare in this way with respect to electron gain enthalpy. Now next physical property we can learn, that is of electron gain enthalpy. Uh, we'll continue this topic electron gain enthalpy. In that more as compared to the group 15 because of the increasing effective nuclear charge, while in case of group 17 it is more as compared to the group 16 because of increasing effective nuclear charge, while in case of group 18 it is minimum in period because of stable electron configuration which are completely fulfilled or completely filled. That's why they have no tendency, means group 18 element has no tendency to accept electrons if their outermost shell is completed. If they have octet saturation, then they are not ready to accept any extra electron in its outermost shell. That's why group 18 are the stable element among all these elements of the group 16, 17, 18. That's why they have that type of tendency which by which they cannot accept any kind of extra electron. Then we can speak about the density. Density of group 16 element increases down the group, and in case of group 17 it is increases down the group. In case of group 18 it is increases from the group. Later on non-metallic character, in that there is decrease down the group, oxygen, sulfur, non-metal also, while decrease down the group in case of group 17, fluorine, chlorine, bromine, iodine, these are the non-metal. And later on in case of group 18 there is decrease down the group and all noble gases are classified as non-metals because of their physical and their physical properties. Later on, metallic character. It increases down the group selenium, tellurium, metalloid. Then polonium is radioactive. Why it is radioactive? That you know, because continuously it emits some radiation due to unstable nuclei. Then, in case of group 17, it increases down the group. So in that, actinium is radioactive. The reason you know why it is radioactive, because nucleus of the actinium is unstable. That's why it is not radioactive. Later on, but such type of effect we cannot see in case of group 18 element. That's why there is blank. Later on, melting point and boiling point. In case of melting point and boiling point, it increases down the group due to increase in atomic size and molecular weight. In that, exceptional cases are there. MP and VP of tellurium is greater than polonium is due to uh, lone pair due to inert pair effect, and it has the intermolecular interaction. Intermolecular interaction among the two atoms that can be causes the exceptional cases about their melting point and boiling point, and that's why tellurium has higher melting point than that of the polonium. In case of group 17, it increases down the group due to increase in atomic size and molecular weight. While in case of group 18, it increases down the group due to increase in atomic size and molecular weight. Later on, physical appearance means how it looks. Oxygen is a gas while other elements are solids at room temperature. Why it is gas? It depends again what density as well as intermolecular forces of the attraction among the two atoms, ions as well as molecules. That's oxygen is the gas. While fluorine, chlorine are gases, bromine is a liquid, and iodine is the solid at room temperature. In case of group 18, all are in the gaseous form at room temperature. Right from helium to radon, you can see all these are our gases in which outermost shell is completed, which is stable. Next physical property we can discuss about their physical appearance. In that, next point is oxygen gas exists as the diatomic. That's why its formula is O2 and molecule, whereas rest all the elements are polyatomic molecules. Then in case of group 17, all the halogen has diatomic form except acetylene, which is monoatomic form. In case of group 18, in that all the elements are in the monoatomic in nature. So it is the major comparison between the group 16, 17 and 18 about their physical properties. Later on, we can discuss about the anomalous nature of first element of the group 16 oxygen and group 17 in that fluorine. In that anomalous nature of oxygen is due to extremely small atomic size, it has highest electronegativity and absence of the vacant d orbital in its electron configuration in its valence shell. On the other hand, in case of group 17, anomalous nature of the fluorine is due to extremely small atomic size, highest electronegativity, and absence of the vacant d orbital in its valence shell. And especially fluorine, it has the low fluorine dissociation energy. It's very important point to compare group 16 from 17. Anomalous behavior of oxygen we'll discuss first. In that, oxygen is a diatomic molecule, while other are polyatomic molecule. For example, S8, AC8, etc. So these are polyatomic, while oxygen is what diatomic, in which only two atoms of the oxygen atoms are required, which can make the molecule. But sulfur molecule we can make by combining of eight sulfur atoms. Similarly, in case of selenium also. Then oxygen is paramagnetic, while others are the diamagnetic. It depends upon their electron configuration, and as per that, their magnetic property we can study. Oxygen shows -2, -1, and +2 oxygen states, while other elements shows -2, +2, +4, +6 oxidation states, which are variable. Oxygen cannot exhibit higher oxidation state due to absence of the vacant d orbital. Then, in same way, we can discuss about the anomalous behavior of oxygen atom. In that, oxygen hydride of oxygen H2O is liquid at room temperature, while hydrides of the other members of the groups are gases H2S, H2AC, H2TE. So these are the gases. Later on, common covalency of the oxygen is 2. In rare gases or rare cases, it is 4. But for the other members of the group 16, the covalency can be exceed 4. Then animal's behavior of oxygen in that it can form only one oxoacid HOF, while other halogens form number of the oxoacids HOClO2, HOBrO2, HOiO2. Then hydrogen fluoride is a liquid. It has boiling point 293 Kelvin due to strong hydrogen bonding, while other hydrogen halides are gases. Later on, we can discuss about the anomalous behavior of oxygen. In that, ionization enthalpy, electronegativity, electrode potential are the higher for fluorine than that of the expected trends shown by the other halogen in the periodic table. Then ionic and covalent radii, melting point, boiling point, and electron gain enthalpy are quite low than that of the expected. Then most of the reactions of fluorine are exothermic, means it can be liberate, it can be given the energy or heat to the surrounding. That's why they're exothermic. So it is also due to the short and strong bond which are formed by it with other elements. The meaning of the short bonds is that which are stronger, and for breaking of the stronger bond, much more amount of the energy is required. That's why this is what it has the uh, more boiling point, melting point we can say, and it shows the exothermic kind of reactions. In next lecture, we can discuss about the chemical properties of the elements of group 16, 17, 18. Till that time, students have to revise what are the we discussed today about the animals about the topics of the group 16, 17, 18, which are in the comparison form of the physical properties. One by one, I am going to revise in short. The physical properties like atomic and ionic radii we have discussed, ionization enthalpy, electronegativity, electron gain enthalpy, electron density, non-metallic character, later on metallic character, later on melting point, boiling point, later on physical appearance. Then we discuss anomalous behavior or anomalous nature of the first elements of group 16, 17, that is oxygen and fluorine. Then in detail we have discussed their anomalous behavior or anomalous nature of the oxygen as well as fluorine, and in that we discuss in much more detail about their MPBP also, as well as exothermic or what kind of nature of the reactions also. Students, uh, you have to revise these topics which are very important, and uh, everybody has to take care yourself. Stay home, stay safe. Uh, all the best. God bless you. Thank you.